Okay, parent function number 2, we're going to talk about the absolute value function, and that is the guy who's got the little hockey sticks up there, the goalpost. Remember, the definition of an absolute value function is say, how far from 0 am I? So essentially, your answer shouldn't pop out of that negative. So let's go ahead and talk about our t-chart. So if you don't know anything about the absolute value function, you can always go back to the t-chart and figure out what this is supposed to look like. So I'm going to plug in -3 into the absolute value function. Again, how far is -3 from 0? It's 3. So the absolute value of -3 produces a 3. So that is an ordered pair. I'm going to graph the point -3 and 3 right there. And I'm going to continue to do that. The absolute value of -2 gets me 2. 1. The absolute value of 0 is 0. It's no distance from itself. And then, of course, I'm going to repeat this. This is going to go 1, 2, and 3. And so I'm going to go ahead and plot each one of those points. And then I'm going to connect my dots. Now, please keep in mind that you're going to put the arrows at the end of these, because even though I stop, doesn't mean I can't take the absolute value of more numbers if I wanted to. I could take the absolute value of 100 and find out that it's 100. So I would graph 100 and go all the way up to 100, but I don't want to do that. So you should get a V shape every single time that you graph the absolute value. And again, what happens is essentially it says when y wants to go be negative, the absolute value says, no, not today. You're actually supposed to be positive because all distances are positive. Now, before I get to the descriptions, let's talk about how to do these parts. Again, you're going to look for your x-intercept. Well, parent function, it's really nice. It's consistent. The parent function has an x-intercept at the origin. It also has a y-intercept at the origin. That's going to happen every single time. Now, part of Algebra 2 is to become really efficient at graphing. So the more you memorize about the parent function, the easier it's going to be to graph any function regardless of what we add, subtract, multiply, or divide it to, which is really nice because then we can just start pumping those graphs out and it works out really nice. Now, let's talk about domain and range, because this is where we're going to see from the picture what happens, okay? So the domain, again, talking about the x-axis. So I'm going to talk about here. This arrow goes up forever in both directions. In order to go up forever, it must have an x value to match it. I had to have an x value to plug in order to get that y value that's going to go up all the way. So if I don't have any problems finding a distance from 0 to any number, negative 922.22, that's 922.22. I can still find its distance from 0. There are no restrictions to what I can plug in. Therefore, the domain is all real numbers. I am not limited because it goes up forever and up forever in both sections, both the negative and the positive. So we can include everybody. However, when it comes to the range, do you notice we're talking about y values now? I didn't draw anything down here. I don't have any negative y values. So I can't claim that the range is all real numbers because all real numbers include negatives, which means there would have to be a drawing down here, and there isn't. So my question, as you read down to up, which is the y-axis, as I go, no picture, no picture, no picture, no picture, oh look, I finally found the first spot where the picture starts. Now the y value happens to be at the origin. So the y value's very first starting point is at 0. And then the function goes up forever. So it starts at the origin and then it branches up until infinity. There's no limitations. The sky is the limit when it comes to the y values. So we would talk about it starting at 0 and traveling to positive infinity. Now I want to talk to you about this notation. 0 I used a bracket for. The reason I'm using a bracket for 0 is because there's actually a value at 0, meaning I can take the absolute value of it. So a bracket means to include. You guys may have learned when you had inequalities, open circle versus closed circle, one has an equal sign, one doesn't have an equal sign, so you had open versus closed circles. That's what they look like in brackets. Brackets mean to include, so it would be a closed circle, and a parenthesis means do not include, so that's like your open circle as far as the numbers it can connect to. So anytime the function exists there, meaning you can calculate it, you use a bracket. The reason I use a parenthesis on infinity is because I can never get there. I can't get to infinity. It keeps going. Every time I think I catch it, it gets one number bigger. So we use a parenthesis saying it goes on forever. Now, we want to talk about this increasing and decreasing. Reading left to right, this guy's doing both. Do you see how this is coming down? That means he's decreasing. But then he stops and he changes direction. And instead of decreasing, he's now increasing. So we're going to go ahead and state where that happens. So he is decreasing. And these are all x values. Everything I'm about to talk about is in terms of the x-axis. So he is decreasing from the negative infinity. We can't see him, but that's where he starts. That arrow is heading towards negative infinity on the x-axis. As he comes in, he comes in until he hits 0. So this is what it would look like. From negative infinity until 0. Now the reason I'm going to use parentheses is because I'm not trying to include something. I have a point that's neutral. That vertex is neutral. There's no increasing or decreasing. It's just a moment. So then it would pick up. So I'm done decreasing. I'm now going to increase from 0, because that's where the switchover is happening, from 0 to positive infinity. Now it's going to go up forever. So I'm going to say from 0 until I hit infinity, that function is now increasing. Next, maximums and minimums. Highest, lowest points. Arrows go up, no high point. We don't max out ever. We keep going up. There's no stopping us. However, I do have a low point. There is nothing that falls below this point. We would call that our minimum. And you would ask yourself, where does this minimum happen? So I have a minimum at 0, 0, which, by the way, also happens. There should be a vertex word on here. So
is that false by octave, is it? No. Okay.
Sorry, someone walked in. Okay. So, vertex right here. I just didn't put it in our chart. The vertex is that point that everything switches over. So be careful there. We would list our vertex and then the end behavior. Let's talk about the end behavior. As x approaches infinity, in other words, the right side. What's going on with the function is the right side. So as these functions come out, where does it go? It goes up, and it goes up forever. So we're going to say f of x approaches infinity. Last side, as we go towards negative infinity, where's the function going? Well, we go towards negative infinity, yet the function is still heading up. So as I go towards the negative or the left side of the graph, the function itself still travels towards positive values. It's still traveling towards positive infinity. Now I'm going to leave it up to you guys to do a description for me, and I'm going to look in your notes for those descriptions. I want you just to put all this stuff into a sentence. So if I needed to graph it, how would you tell me? Miss Mzoris, it's an absolute value function. Its vertex is here. Its x and y intercepts are there and there. Its end behavior looks like this. Make sure you're going through the vocabulary and checking things off through your description. Now, these are just parent functions. We've not talked about transformation. We'll save that for another day. We will take our assessment tomorrow. We will practice a little bit of domain and range, and then we're going to practice parent function graphing and start talking about transformations. All right, thanks, guys.